All right, so a chain of sports stores is looking for a profit into the profits at the Ringwood, Carlton and Bayswater stores for the months of January 2016, and below is all the items and at each store. And now when it says represent this table form in Matrix, it's pretty easy. You just have to put pretty much a table, but just make it into matrices. So it does say you need to sort of label it. So we might like put something like that. And then you just pop in the numbers. So really all you need to do is pop them into those square brackets, and that's fine. So I know it seems pretty basic. Some kids just get a little bit, it's so easy, it's a bit of a loss, but that's all they're asking there. All right. This is what you will have a question on this. So it's the solve the following simultaneous equations and express your answer in matrix form. So it's really important that we show all our working out for these questions. So when we have simultaneous equations, what we can often call it as the setup. So this is not how you solve it, but these are these equations in matrix form. So what you do is your first matrix has all the numbers that are going to be in front of the x, z, and the y. So just be careful because it's a little bit jumbled all up. So in that first equation, 1 is the number in front of x, z will say 3, and y is -2. Now the next one, 2, -1, and 3. And then the last one is -1. There's 2 z's and there's no y's. Now, when we do this, we have to make sure that the order that's gone across here will be the order that goes down here. So because I said x, z, y, I need to pop in x, z, y there. Okay? So if you've got it, if you did x, y, z, that's fine as long as all the numbers are matching for the correct thing. And then we have 14, 7, 15. So that is the setup. Now, if you are actually going to solve it using matrices, solving would mean we're trying to find what x, z, y is equal to. So remember that it's the inverse of this first one. So you would write, you'd write this out to -1 and then times by the 14, 7, 15. So you just do that straight into your calculator. So you type this into your calculator with the power of -1 and your times, and you'll end up with your answer. So if I did that, so you'll end up with 1/3, I think 23 on 3 or 14 on 3. Okay, so it doesn't matter if you've got decimals or it didn't say, or fractions, that's fine, whatever it is. But mainly you need to show the working out, so that's important, so do that. All right, with this next one, a Coffee Drinkers Association Victoria completed a survey of 2,050 people to understand their buying habits. The initial results for March 2015 are shown, and then the survey found that people change their preferences from month to month, and that's shown down here. So what this is transition matrices. Okay, so this is setting up transition. So here they gave you your initial state, so that's SO, and down here is going to help you set up your transition matrix. So it says represent the information they gave you. So they gave you it in table form. Sometimes we're used to seeing, say we had an espresso, and we used to seeing that they do it like this, where they say 77% go back to Nespresso, and maybe when it goes, say Gloria Jeans, we might say if you go to Gloria Jeans, it's 7%. So 7% of Nespresso went to Gloria Jeans. So we're used to seeing it in a diagram like that, but we've got it in a table form. So to set up the transition matrix for this, so you've got to have your companies or whatever it is. So I've got Nespresso, Gloria Jeans, Coffee Clubs, and Aldi Pods. And then you'll have the same across the top in the same order across like that. Okay, so if you remember back, we can't put percentages, we change them to decimals, because who remembers what in a transition, what do our columns need to add up to? Who can tell me? Anyone listening? One, thank you. So, and if you remember back, it's often easy to do the ones that go back to themselves. So that's these ones here. So 77% go back to Nespresso, and then Gloria to Gloria, 64. Coffee Club to Coffee Club is 60, and then Aldi Pod to Aldi Pod is 0.58. Okay, so they're often easy to put those ones in, and they'll be on the diagonal. Then we've got starting, so we sort of say start and end here. So if we start at Nespresso, 7% go to Gloria Jeans. Oh, sorry, no, I've done that wrong. So we've got here 7% go to Gloria Jeans. Sorry, go down here. And then we've got 8% go to the Coffee Club, 0.08, and Aldi was also 8%. So you'll see they all add up to 1. And then we do the next one from Gloria Jeans to Nespresso is 12%. So that's 12%, Coffee Club 1.6 and 0.13 there. And then we've got Nespresso to Coffee Club was 8%. Oh no, which one am I doing? Sorry. Coffee Club to Nespresso is 16%. And then 4%. Then, what am I on? 20%. And then the last one is 0.13, 0.10, and 0.19. So there's your transition matrix, which we've set up, and we've got SO here. So SO was the beginning of March. So just remember SO is March. Okay, this one here, we type that in, which was 800. We are asked, so when they say May, so if you think March, April, May, so this was 0, 1, 2. So we want to get, May would be state 2. So if you were working out, you really want to find state 2, which is, I'll just call right there that it's May. What you're going to do is you're going to do the transition times SO, which was the March situation. So we're going to type in that big transition matrix in our calculator, and then we times it by SO, which they gave us, 800, 400, 550. Okay, so you don't need to write out the whole transition in your sack. You can just use T like that. Maybe write the SO. Now we want to, because we want to do S2, we want this to be the power of 2 when we're working it out. Sorry, I should put that there. So if you remember back what we said this number and that number should add up to what you need. So 2 plus 0 is 2, so that's good. And if you do that, I'll just write it over here. So S2 ends up being, now we're talking about number of customers, so we'd probably round to the nearest whole number. And so we pop all these in there like that, And there we go. And there's our thing. So it says calculate the number of customers drinking each. So this was Nespresso, Gloria Jeans, Coffee Club, and Aldi Pods. And we probably, in a sack, you should probably just write that out. At least have the NG, the Gloria Jeans, and that indicating it down there like that. All right. And then it says calculate the preferences in the long term. So long term is when we get the transition to a high power. So I'm just going to pick 50 and times by SO. Okay, so if I do that, and so I do the transition to this high power and I times it by that SO, which was the March one. Okay, we'll end up with an answer. And once again, I'm going to round to a whole number because we're talking about customers, so people, and 475. So you should end up with this answer. So, and it says calculate the long term. So we should again just indicate along the side which one's which. Maybe even if you've got time, write out a little statement. 770 for Nespresso, 334 for Gloria Jeans, and so on. All right, so that's like a transition question that you'd probably get, something like that. Okay, this one up here, we're going to start looking at just a few things. So we've been given a few matrices, and it's asked me to find the inverse of matrix C here. So we need to remember the inverse formula. It's 1 over the determinant, where we swap these numbers and we make these numbers negative. So this is if we had a matrix that looked like that. Okay, so you probably, because it's a SAC and we want to see that you understand, you probably need to show all of this out. You can check on your calculator that you're right, but let's show the inverse. So first we need the determinant of C. So remember the determinant is A times D minus B times C. So in this case, it's 1 times 8 minus 9 times 4. Okay, so we get 8 minus 36, which equals negative, what's that, 26. Okay, so then when we go to find the inverse, I'm going to write 1 over negative 26. Then I'm going to swap these numbers around. So I've got 8 and 1. Then I'd have negative 9. I make these ones negative. Okay, and then if you keep stepping that out, we would just times it out. So it ends up being like 1 over negative 26, negative 9 over negative 26, negative 4 on 26, and 1 over negative 26. But if you then chuck it, if you've checked it in the calculator, which I hope you do because you're, it's a SAC and you want to get the right answer, if you do that, it'll simplify down to, is this 28? Sorry. Anyone pick that up? Sorry. So that's 28. So it'll simplify down to negative 2 on 7, or if you've got it in a fraction, a decimal, that'll be fine too. Okay, so in further we accept both. All right, so there's that one. With this next one, when you're asked to find like 2a minus 3c, this is when we would just straight away go on our calculator. All right, so with this one, we've got no d, but they want you, so we need to calculate what d is. So this is the unknown. Now we've got everything else because we've been given. So what we do is just do it like you would do it as a normal equation. So if you moved that over, that would be minus. So I'd be left with 2dc equals b minus a. Okay. Now if I was trying to get D by itself, what I would do is this is the two here. The 2 here and that C is multiplying. So if it's moved over, it will. So if it's moved over an equal sign, it will divide. So what you're actually doing is you've got the B minus A and you're dividing by 2C. Now, you know in matrices we don't divide. Matrices is when you divide, you use the inverse. So really what's going to happen is you're going to be, because the 2's at the front, it'll be like using a 2 there, and you'll still, so 2 times, you'll still have matrix B minus A. You would have done that. And then what you're doing, you've also got to divide by C, which is like timesing by the inverse. So I'm going to times by matrix the inverse. Now, but see, because C is after, I'm going to do it after. So all I do is pop that expression into the calculator. So I'll show you what I mean. I'm going to just, a study conducted in April on a consumer behaviour of people who watched and download movies. The study found that 400 people used Netflix, 700 used Foxtel, 900 used iTunes Store, and 1,000 people used torrents to download films. Show this information in initial state matrix. So they're asking you to call it SO, and that's easy. So we'll just put 400, 700, 900, and 1,000. And what we'll make sure, we just put the initials down there, that was Netflix, Foxtel, iTunes, and torrent, okay? It was found that the survey that consumers changed their habits. So this is setting up a transition again. So what we're going to do is we'll get our transition matrix going. So we're going to go, so we generally say start and finish. That can help you with transitions. So we'll have our Netflix, Foxtel, iTunes, and torrent, and that would be the same down here. Netflix, Foxtel, iTunes, and torrent. Alright, so let's go through it. If it says 40% of those using Foxtel, 70% continue their subscription. So Foxtel to Foxtel, that pretty much told me. So Foxtel to Foxtel was 0.7, where they said, well, 10% would try Netflix. So you were Foxtel, and then you went to 10% went to Netflix, and 5% to iTunes. And if, yeah.
Is the start always in the front?
Yeah, for transitions.
Yeah.
Yeah. Okay. And what do the columns need to add up to? They've got to add up to 1. So even though they didn't give me the rest switch to torrents, here at the moment, going down here, like that's 85%. So if it's 85%, then this must have to be 0.15, so it will add up to 1. And that's how I work that one out. Okay, so if we do the next one, of those using iTunes, 55% would continue. So I to I was 55%. Then it said 25% would use torrents. So 25. So I'm already up to 80. And here it said 10% Foxtel and 10% Netflix, which is good because that ends up adding up to 1. Okay. Those using Netflix, 60% would continue. 15 would go to torrents. 15% would use Foxtel. So I'm up to 90%. And then it said the rest would use iTunes. So if I'm up to 90%, that's got to be this one, I'll do it in red. That had to be 10 because it has to add up to 1. Okay, and then the last one, 85 to 85 to use for torrents. And 15% was split between the other services, so that means 0.5 because it goes evenly. Yeah, evenly, it was split evenly. So there's my transition. So we've worked that out. And in the calculator is this transition to the power of 6 times that SO. So if you go back to SO was April. Yeah? Calculate S6. So all we know, we just have to do, you don't need to write the whole transitions out. You can just do that. Okay? So what you would be told, and hopefully you'll end up with your answer. And plus these are people, so go to a whole number. And you'll get this. Okay? And so remember Netflix, Foxtel, iTunes, and torrents. So which month does this answer represent? So if we know SO was April, then you've got 1, 2, 3, 4, 5, 6. So April, May, June, July, August, September, October. So which month does it represent? You just write October, like that. Okay? Just to be safe, just write it out. It doesn't take long, just do it like that. All right, question 9. The following matrix represents the Supercoach points scored per round for 3 AFL players, round 1 to 4. So here I just like to put what that is so I can see. Write down and evaluate the matrix product for the total points for each of the players over the 4 rounds. So they want you, so you've got to think about it. They want the total points for each player. Okay, so really what you want to have is you want to have the total points, and then you want to have Ablett, Selwood and Pendlebury. So, which would mean you have an answer here, an answer here, and an answer here. So that is a 3 by 1, okay? And if you look at it, just sometimes the rows are the players. So when you do a matrix, because they want a matrix product, that means a multiplication. Now I want those rows, so remember, so I'm going to go with this matrix P first. And this matrix P is a 3 by 4. Okay, so it's a 3 by 4, and I'm going to multiply it with another matrix, but what I want the answer to be is a 3 by 1. So I'm taking, this is how I got that. So therefore this matrix, I want a 1 there, so it has to be a 1. And if you think about it, this needs to be a 4 for me to be able to multiply. Now because I want to, so now I know I've got a 4 by 1. So I've got 1, 2, 3, 4 down here. But I want to add all the points, so when I run across there, I'm going to dive down this 4 by 1 matrix. Now if I want to add these up, it means I really want to times them all by 1, because it'll go run and dive, that would be. So you end up, you want to see a matrix like that. And then you can have your answer in. So you can just do the P times like what I wrote like there, and you can pop in your answer. So 5, 2, 3, and you should be able to just, you know what it should be, because it's pretty easy to add it up. It's not like they're asking something complicated there. So work out what your answer should be and double check. All right, the next thing it says is using a scalar, calculate the average. So a scalar is when you have a whole number, like a number. It's just a number. It's not a matrix. Okay? So, and used to find the average. So if they played 4 games, you'd add up all the games. So an average is when you add them all up and you divide by the number of games. So it would be, now this matrix has added them all up and we want to divide by 4. So really, to divide by 4 means you want to times by 1/4. So here is what you're doing. And because this number here, that is a scalar. Okay, when you're timesing by a number, which is 1/4, that's the scalar. So that's what you want there. Okay, let's do this one. So there will be a dominance. So let's have a look at this. The results of a round robin basketball competition between teams A, B are represented below by the network graph. Use the diagram to construct a dominance. So this is one step. So one step dominance is when you just do the very first scenario of what actually happened. So we often call it D, and they've asked us to do that. So we're going to have our teams, so A, B, C, D, and E. And the same is you have across here A, B, C, D, and E. Okay, so if you look at here, this is the winner across here. So if you go across, so if you have a look, let's go have a look at A. So here's A. A seemed to have beaten, sorry. So I want to change that to, get out of there. This up here is the winner. So if you look here, A beat E. A beat D. So we'll put a 1 there. A doesn't beat themselves. No, I don't know how I don't know how you want to look at it. It's winner, and then you go across this way, okay? So A doesn't play themselves. Did A beat B? No. Did A beat C? No. And A did beat B, didn't it? Sorry. There's a few games played here. Can you see that, boys? No? There's a win there. A beat there. So there's, this one, Rabbit Mount. There was a 1 there. And that was it. And it didn't beat E. Okay, so let's look at B now. B beat D, and that was it. So B beat D, so 0, 0, 0, so it won there. Okay, going across C. C, it beat E, beat B, it beat D, and it beat A. Looks like it beat everyone. So, except for itself, obviously. And then we go to D. D beat no one. Okay. And E, who did E beat? A, B, and D. All right, so there we go. We get the first one step will be the harder one. When you go to do down here, they ask you to construct D2. You simply just have to square your matrix 1. So I'm going to go in here and set up this matrix, which is a 5 by 5. And I just type in my first one, and it's much easier. Also, we'll just type that in, and you're going to have to do this. So Okay, so that's D. If I want to get D squared, I just square it. And there, I'll just copy that out here. So D squared would simply, and you just copy out, make sure you copy it correctly. And you'd write that out. 1, 2, 0, 3, 0, 0, 0, 0, and 0, 1, 2, oops, 0, 2, 0. Okay, if they want the total, if you wanted like the total 1 steps, that would be going along here. So this one would be 2, this one would be 1, this one would be 4, 0, and this would be 3. If you want the total of 2 steps, you just add up these ones. So this would be 1, 0, 6, 0, and 3. But often they say the winner is the 1 and 2 steps, which they ask you here. So all you have to do is you just do it on your calculator. So they want the total, and they're saying it's the D matrix plus the D squared. Okay, so if we do that on the calculator here, so I just go that one, that was the first one, plus the squared one, and then you get the answer. So you write out what you have there. And this is the total of 1 step, 2 step dominance. And this is often what they say will determine a winner of a tournament. And they will also say you might get asked to rank them. So if I do the totals here, we've got 3, 1, 10, 0, and 6. Okay, sorry, going back here. So, and remember this was A, B, C, D, E. So there's the total rankings, and then it says you might have to determine. So I might say first place was C with 10 points, or 10, with 10. Second place was E with 6. Third place was A. Fourth place B, and fifth place was D. Okay, so there's your ranking, and that's what they might get you to do. All right, gonna pause there. Okay, so with this one, we've got simultaneous equations again. So, as I said, it's practicing that. So let's have a look. Peter bought tickets from upcoming Taylor Swift concert. There are 2 types of tickets, adult and concession. He bought tickets in bulk and does not know the individual prices. Peter knows that he bought 4 adult tickets and 2 concessions for $600, and then he finds out his friends bought 3 adults and 1 concession for $400. Express the information in 2 simultaneous equations. So what we'll do is you just write it out. So we might say 4A plus 2C equals 600, and then we might say 3A plus C equals 400. Okay, is that beautiful? We've done that. It then says write these equations in matrix form. So this is like setup. So you're not solving it. They just want you to set it up. So you have the numbers that are in front of the letters here, and then we'd say we times by the letters, and we say equals the answers. Okay, so that's what they want written there. For the matrix in part B, so here they want me to find the determinant. So remember, the determinant equals, and now they're talking about this matrix here. So it'll be 4 times 1 minus 2 times 3. So that'll be -2. And then it says find the inverse. So remember, the inverse is 1 over det. Then you swap them and you make them negative. So if I go to write the answer, I'll have 1 over negative 2, and then I'll swap those numbers and I'll make these negative. And then I might keep going and just show that I know. So it's negative a half, negative 2 on negative 2, negative 3 on negative 2, and 4 on negative 2. And even that will simplify down to negative a half, 1, 3 on 2, and negative 2. Okay, so you'll end up with that answer. You just probably need to show you're working out a little bit, like at least to this point, and then you can chuck it in the calculator and let it fix it. And then all right, when it says solve, that's where we might just show, it was adult and concession. We might just show that what we would do. So we know if we're just quickly solving it, we just chuck that into the -1 and we times it by 600 and 400. Just show what you're doing there, and then you get your answer, which should be 100 and 100. And then just write out the price. So that was A and C. So adult was the same price as concession. And there you go, it just happened to be the same price. So let's do the next one. If mum is late and is picking up her children from school, L, on a given weekday, there's a 5% probability that mum will be late on the next weekday. So this is transitions again. Okay, so we're setting up transitions. So if we're going from late, that should be late on the next day. So L to L is 5%. Now, so if she's going to be 5% late, because these have to add up to 1, that means on time is 95%. Okay? And then there's 25%, if she's on time today, she's 25% late the next day. So there you go. On time today, 25%. So these have to add up to 1. So that makes that 75. All right. So then they've got, in a given week, mum arrives on time on Monday. So, and they said that the probability that mum will arrive on time on Wednesday, the matrix that describes mum being on time on Monday is here. So when she's on time and late, because you know she's on time on Monday, that means it's 100% that she's on time. That's why there's a 1 there. So the probability is 1. So this is like your SO. So if you think about it, if you've got Monday, Tuesday, Wednesday, this is SO, this must be S1, this is S2. So if you want to find S2, you'd be doing the transition to the power of 2 times your SO. So in this case, it'll be that transition that we found out, and to the power of 2 times your SO. And you end up with this 0.8 and 0.2. Okay, so if you think that was on time, and that was late. So it asks for the probability that mum will be on time. So probability of on time, you can just write the decimal, that percentage, the decimal, so it'd be 0.8 is the probability, or 80%, but just leave it as 0.8 because that's what we write probability. Given that mum is late on Monday, so now they're changing this. So given mum is late on Monday, find the long term. It shouldn't matter anyway, but when we do long term, we do the transition to a high power, might just do 50, and times a state matrix. So remember, on time, on late. Now they said mum will be late on Monday, so I'll just write that. and we'll find our answer. So let's do that. So we ended up with 0.79 and 0.21. So, but the question was, what's the probability she'll be late in the long term? So probability of being late, just make sure you pick the right one, which was the bottom one, so 0.21. Okay, let's set this one up. So, or is it might be dominance or communication. Below is a network diagram that results in the tennis tournament. So it is dominance. Okay, so when you know it's a game, maybe just write that it's dominance. When you have dominance, there's always there's a winner. So there's got to be a 1 and a 0 between the two letters. In communications, sometimes it can be both ways. So it means the 1 can be on both letters in partnership. So let's have a look. So remember we said, so if you win, so A, if we go across, A didn't play himself, but did beat B, and did beat E, and also beat C, but not D. Okay? So B beat E and D, and that was it. Okay, C, if I look at it, only beat, only beat B. D beat, it beat A, didn't beat B, beat C. And then the last one, okay. So this is, you set up your D. So you've got your D mate. Look, that means B, if you look at B, has beaten 2 people that beat C. And if you have a look, see how B beat D, who beat C. So there's that one, that's one of the 2-step options. Okay, and if I look at another one, B also beat E, which also beat C. So there's the second 2-step. That's the second two-step option. So there's why there's a 2 there. So what it means, next question is they want D squared. So we're just going to pop that in again into our calculator, the D, and you'll raise it to the power of 2. And when you do that, you'll get the following answers. So I won't bother. I think you've got that on the calculator. You understand how to pop it in. So hopefully you end up with this answer. Now, it asks you to explain what D squared means, what actually means. So I'll go back and I'll explain something to you. So if I look, I'm going to pick one. I'm going to pick this one. Between B and C. So B has 2 options of 2-step dominance over C. So if you go, when they ask you, they say, explain what D2 matrix is. So you might say D2 matrix is 2-step dominance. So you probably write that is, and then you might just write this is when one player is dominant, one player dominates a player that has beaten someone else, has beaten another player. Okay, so that's what that means. Okay, so you sometimes do get asked that, so probably good to have a bit of an understanding of it. Okay, then they ask you they said that the tournament will be decided if you add the D and D together. So if you do that, and you just do that on your calculator, hopefully you'll end up with this matrix here. Oops. Okay, all right. So remember this was A, B, C, D, E, and then you can work out their totals. So the total for this one is 7, this one is 6, this one's 3, this one's 8, and this one is 2. So who's the best player? Best player is D. Is D. So with this question, it is, you've got 4 country towns with A, B, C and D, and natural gas is stored for emergency during colder months. Gas can be pumped from one town to another, necessary as shown in matrix M. So this is actually an example of like a communication matrix. Even though it's talking about gas, it's talking about like something's connecting with something, and you can go vice versa ways, okay? Or it could be pumped to one town, but it might not be able to be pumped back and things like that. So this is a communication matrix. So let's have a look. So you can see here, they're going, you start here and then it goes to there. So if it was talking, you might call this the speaker and this the receiver, yeah, like that. So if it was communication. So we've got to, the first question says, use this like diagram, the nodes, the circles, and make a network diagram given this communication matrix. So if you said gas from A can go to B and D, so what I would draw is an arrow from A to B, so I know that it goes that way, and also from A to D. So I've done that, those two, and then it says we've got, I'll just do it in a different color. So B goes from from B to A, so that means we can also go that way. So in a communication. In dominance, you don't have a two-way arrow. Someone wins out. So that's probably the biggest difference. So B can also go to C. So I might draw an arrow there. And if I do this C can go to A. So C can go to A. And C can also go to D. So C can go to D. And just fine. And then the last one, D can go to B, so just that way. Okay, so what they've given you here when we're talking about, because this is a communication, so as soon as it can go, this is not like a win out situation. Dominance is pretty clear, it's a tournament sort of game thing. So when this is actually this is like the first communication matrix. So you might say this is step 1, communications. So this is exactly what can happen. So we call it step 1, communication, or we call it the C. Okay, now they've actually called it M here, so we'll just leave it, doesn't matter, they've called it M. Now down here, they're asking us to find matrix P, which they're saying is matrix M plus M squared. So really, it's like saying when we have communication, we say total, I'll just write it over here, total communications is often referred to as when you add step 1 plus step 2. So step 1 and step 2 communications, 2-step communications, I should say. So this is what they're mimicking here, but they're just calling it different letters. All right, so we're going to go pop that communication matrix 1 into our calculator here. So when we did this, we end up with this matrix. We added the squared one and the normal one, and we end up with 1, 2, 1, 1, 2, 1, 1, 2, 1, 2, 0, 2, and 1, 1, 1, 0. So if we think about it, this was the towns like A, B, C, D. And what this is telling me is how many, this is, well, when you're adding up, you can see who can get the most gas from 1 and 2 step situations. And then you just add across the line. So you just add across there. So that one is 5, 6, 5, and 3. Okay. So that was what that. If we go to the next, they're probably actually talking about this one. I'll grab this one. Out of the question, it says, why is the diagonal elements not useful in the context? So I'm just going to grab. Okay, so they've asked me, why is this diagonal? And it's same even with the squared one and even the end product. Why is that not useful? So I probably... Okay, so they're saying, why is this one not useful down that diagonal? And that's just because it's it would be pushing gas back to the same town. So that's not there's no point going back to the same town if it began there and they're the ones pushing it out. So would write that. So that's, remember, we call that the redundant link down that. That it means it doesn't really make sense in the situations because it's always going back to where it originally started from. So in communication, it would mean you're communicating back to yourself. So it's sort of pointless. Okay, so there's no point in a town pumping gas to itself. All right, it says, using your results from B, which town is most at risk at having least gas during the winter, and explain. So I'm going to go with D, because D can only get gas even in a 2-step situation where it's going to push to one town and then on to D. It still has the lowest amount of options. So town D, this is where it would be a minimum. So you're going to say town D, as it only gets gas from 3 other towns. Because this is a total of 1 and 2 step communication, or communication movements, whatever. So it's only getting it in 3, there's only 3 options for it to get gas from other, whether it's in a direct link and it can only directly get it from B, and then it's got 2 other options where it gets it from another town that's got it from another town. All right.